equation. So in this video, I am going to explain about the remaining parts in the Einstein equation, right? So in the previous video, I find the ratio between the N1 and the N2. So N1 to N2 is equal to exponential of h nu by kT. Okay. So this is the number of, so this is the ratio between the N1 and N2. So this is the equation number 2. Okay. So now the atomic level and the atomic system is exposed to the light radiation. So what will happen? So it will involve the three quantum process, right? So first process is stimulated absorption, then spontaneous emission and the stimulated emission. Okay. The first process is stimulated absorption. Okay, we know that stimulated absorption, right? So we have two energy level. So E1 and E2. So N1, the number of atoms in the ground state is N1, the number of atoms in the electric state is N2. So the normally atoms are present at ground state. Okay, so now the ground state molecules are stimulated with h nu of energy, and this ground state molecules excited state. So this process is called as stimulated absorption, right? So now N stimulated absorption, the system absorption, the number of atoms density, the absorption density is directly proportional to N1 because the transition is takes place from N1 to N2. So this is the upward transition, right? So upward transition, right? So NAB is directly proportional to N1 into the Q. So Q is nothing but the light radiation density of light. Okay. So N1 into Q. Okay. So NAB is directly proportional to N1 into Q. So N1 is nothing but the ground state. The Q is nothing but the density of light radiation, right? So NAB is equal to B1 to N1 Q. So B is nothing but the proportionality constant. So already I said that. So A stands for spontaneous emission and B stands for stimulated. So this will be the stimulated absorption. So we have used the coefficient B. So here I have mentioned 1 2 because the transition takes place from first level to second level. I have so that I have mentioned 1 2. So B1 to N1 Q. So this is equation number 3. Okay. So the second process is spontaneous emission. Spontaneous emission. So in spontaneous emission, E1, E2, N1, N2. Okay, the excited atom without any external influence it comes to the original state by emitting the exchange of energy. So here, so NSP is nothing but the density of electrons in spontaneous process. Okay, NSP is directly proportional to N2 because so this will be the downward process. The transition takes place from N2 to N1. So this will be the downward transition. So this will be the upward transition. So this will be the downward transition. So here we will not use any direct radiation. So we have not mentioned here Q. Okay. So NSP is directly proportional to only N2. Okay. So NSP is equal to. So we already said that. So this is the spontaneous process. So I have mentioned the coefficient A. Okay. So A. So the transition takes place from number 2, second level to first level. So 2 1 N2. So this is equation number 4. The next process is stimulated emission. Stimulated emission. So in stimulated emission, so we have filtered the excited atom with the mixing of energy. Then it comes to its original state. Okay, by emitting the highly energetic photon. Okay, so here NST is directly proportional to N2 into so Q because so here the light radiation will be involved here. So that we have mentioned the Q here. Okay, so NST is equal to B21 N2 Q. Okay, because the transition takes place from second level to first level. So this also the downward process. So B21 N2 into Q. So this is equation number 5. Okay. N2 plus B21 N2 Q. So including the Q terms, so B12 N1 minus B21 N2 into Q is equal to A21 N2. Okay, so now we stand Q here. So these terms are this side. So A21 N2 divided by B12 N1 minus B21 N2. Okay. So let's simplify this equation. So Q is equal to A21 N2 divided by. So we will take this term outside. So write this equation B21 N2 is equal to B12 N1 B12 N1 divided by B21 N2 minus 1. Okay, so now N2 and N2 get cancelled. Everyone is A21 by B21. So 1 divided by B12 divided by B21 into N1 by N2 minus 1. So substitute N1 by N2 here. So now Einstein equate that. So B12 is equal to B21. That means the stimulated absorption will be equal to the stimulated emission. So he states that the stimulated absorption will be equal to stimulated emission. So substitute here. So these two terms get cancelled. So substitute N1 by N2 here. The Q is equal to A21 by B21. 1 divided by the N1 by N2 value will be e power h nu by kT minus 1. Okay, so this is the energy density. Okay. Okay, so now by Planck's law, the energy density Q is equal to 8 by h nu Q by CQ 1 by e power h nu by kT minus 1. Okay, so this is by Planck's law. The energy density is equal to this equation. So this also energy density, this also energy density. So this equation must satisfy the Planck's law. So equating these two equations, so these terms will be cancelled because all are same equation. So the remaining terms are A21 by B21 is equal to 8 by h nu Q by CQ. Okay, so this will be the Einstein's A and B coefficient. Okay, so from this equation, so Einstein concluded that the spontaneous emission, the rate, so he gives the data between the spontaneous emission to the stimulated emission. The ratio between the spontaneous emission and to the stimulated emission is equal to 8 by h nu Q by CQ. Okay, so now he also states that the stimulated absorption is equal to stimulated emission. So these two also equal, and he gives the information about the ratio between the spontaneous emission and the stimulated emission. So this is the Einstein's AB coefficient. So he states that the energy density is equal to the quantum level of particles. That's it. Thank you.